Okay, so the first thing we're going to do is factor where possible. So this is going to be a long question, and we've got 4 different polynomials that we might be able to factor. So kind of off to the side, let's see what we can do here. We've got 2x squared minus 6x plus 5. Now, if I multiply 2 and 5, that's 10, and I can't think of two numbers that multiply to 10 and add to 6. The only numbers that multiply to 10 are 10 and 1 and 2 and 5, and neither of those can be combined to give me a 6. So now I'm going to check my quadratic formula, b squared minus 4ac, my discriminant, and b squared is negative 6 squared, which is 36, minus 4 times 2, which is 8, times 5, which is 40, and 36 minus 40 is less than 0. So this first part is not factorable, so I'm not going to mess around with that any further. So I'm just going to write 2x squared minus 6x plus 5, the numerator on the left. Okay, on the bottom here I've got x squared plus 10x plus 9. So now I'm hoping this is a simple trinomial, looking for two numbers that add to 10 and multiply to 9. That's easy, 9 and 1. So I can rewrite this as x plus 1 and x plus 9. 1 plus 9 is 10. 1 times 9 is 9. So I've got x plus 1 and x plus 9. Beautiful. Nothing's canceling out there. On the other side, I would like to rewrite this in proper descending notation. So that's negative 3x plus 2. And anytime we like even negative 1 is a common factor. So I will factor out that negative and be left with negative 3x minus 2. So I've got negative 3x minus 2 on the numerator on the right. And then last function we're left with is negative 3x squared minus x plus 2. So again, I'm going to factor out that negative and be left with 3x squared plus x minus 2. Sorry, guys, there's an announcement. I don't know how loud that is for you. Okay, so 3 times 2, negative 2 is negative 6, and my middle number is positive 1. So I need two numbers that multiply to negative 6, add to positive 1, and those two numbers are going to be 3 and 2. So positive 3, negative 2. So I'm going to rewrite this as 3x squared plus 3x minus 2x minus 2. So I've not changed anything. 3x minus 2x is just 1x. And then again, I've got that factor by grouping. So I can factor out a 3x in the first two terms and be left with x plus 1. And I can factor out a negative 2 in the second two terms and be left with an x plus 1. And then I can factor out that x plus 1, negative, and I'm left with 3x minus 2. Okay, so in the denominator I have negative x plus 1, 3x minus 2. So would you look at that? These factors can cancel out, and this is just a negative 1, and negative 1 divided by negative 1 is just a positive 1. So all of those have now canceled out, which is wonderful. And I'm left with, and actually I just want to show you guys like why that works. Let's just say we had like negative 20 divided by negative 4. Well, we know the answer to this is positive 5, but this could be rewritten as negative times 10 times 2, for example. Those could be factors. And this could be rewritten as negative 2 times 2. And negative 1 divided by negative 1, those could cancel out. And the 2's could cancel out. And what we would be left with is 10 divided by 2, which is 5. So when things are factored out, when it's multiplication and you have the same factor top and bottom, they cancel each other out, and then that's how we end up with this division. So we can cancel out factors in that way because they are being multiplied. It does not work when you are adding and subtracting. So what we are left with is 2x squared minus 6x plus 5 divided by x plus 1 times x plus 9 is all equal to, those both canceled out. It doesn't mean there's nothing left on the top. It's a 1 over, and the only thing left on the bottom is x plus 1. Oh, geez. X plus 1. Okay, so this is nice. I've got an x plus 1 on both sides, and ultimately I'm trying to isolate everything to one side. So if I multiply by x plus 1, let's try and get rid of this variable in the denominator right now. If I multiply that side by x plus 1, I need to multiply this side by x plus 1. Those cancel out. Notice that those will cancel out as well. So now I've got 2x squared minus 6x plus 5 divided by x plus 9 is equal to 1. So now what I'm trying to figure out is, when is this rational function equal to 1? And again, I still have variables in the denominator. I don't want that, so I'm going to multiply left and right by x plus 9 so that those cancel out. And now I've got 2x squared minus 6x plus 5 is equal to x plus 9. Now I actually have to bring them back over here because I'm trying to combine this to one single quadratic. So I'm going to take away x on both sides, and I'm going to take away 9 on both sides. And I've got 2x squared. Negative x minus x is negative 7x. 5 minus 9 is negative 4 is all equal to 0. So now I've got this quadratic, and I need to factor it still to find the solution. So 2 times negative 4 is negative 8. So I need two numbers that multiply to negative 8 but add to negative 7. So that's going to be negative 8 times positive 1 and negative 8 plus 1. So I can split this up, and I have to decide the order. Do I want it to say 2x squared minus 8x plus 1x, or do I want it to say 2x squared plus 1x minus 8x? And because the 4 is here, I'm thinking the 4 and the 8 are going to go well together. So I'm going to write it as positive 1x minus 8x, and that still is going to simplify to that negative 7x minus 4 is equal to 0. And if you have a different method for factoring complex trinomials, by all means, I'm just using decomposition because I find it fastest. So now I'm going to factor out this x here, common between the first two terms, and be left with 2x plus 1. And in the second two terms, I can factor out a negative 4. And when I redistribute, negative 4 times what would equal negative 8x? That would be, 2x, and negative 4 times what would equal negative 4? That would be plus 1. And now what is common between these two terms is 2x plus 1. And when I factor those out, I'm left with x minus 4 is equal to 0. And when I figure out when will 2x plus 1 equal 0, that happens when x is equal to negative 1/2. And when will x minus 4 equal 0? That is when x is equal to positive 4. So there are my two solutions, which again ultimately represent when this function, we'll call it f at x, is going to intersect with this function, we'll call it g at x. So if we want to state our solutions, we could say therefore f at x and g at x will intercept when, or at, but when x is equal to negative 1/2 and 4. And you guys, of course, can go ahead and check this on Desmos. You could put this function in, you could put this function in, and see where their point of intersection is. Just to save you guys time, I'm not going to do that. And again, there's your practice question. So do make sure you practice this stuff. And that's everything for lesson 5.